if we take a data, okay, so just entering inside the statistics, let's see some introduction about the data analysis. So if you take about the data analysis, it's very pretty clear, like the data will be like categorical in nature or like a numerical in nature. Okay, and in certain cases, input will be like a combination of the both the numerical and the text sort of a thing. And finally, we'll be getting the output. So again, output may be categorical or quantitative in nature. So whenever we take any data set, hope I'm audible.
Yes, ma'am.
Yes. Okay.
Yes,
So
ma'am.
yeah. So whenever we consider any data, okay, whenever we consider any data, the first step as a data analyst or as a scientist, data scientist, or like in researcher point of the view, first we should analyze the data manually. Okay, we should check like manually in sense by seeing like we can identify the certain pros and cons of the data. So first we have to check like how much of missing data is there. Okay, so once we fix about this missing data, if so much of missing data is there, so how are we going to handle that missing data? So this is only a common things which will be done in the case of the data pre-processing stage. So once that we are fixed with the data, okay, our data is perfect, then we'll be going on with the other techniques of either applying the machine learning to that or applying the deep learning based on the requirement point of the view or based on the objective point of the view. So coming on with this data sets, okay, coming on with this data sets, so we are having n number of data repositories to provide us the data. So basically we all would have dig with the UCI data repository, and then we would have discussed with the Harvard data sets, we would have discussed with the Menley data sets, and we would have discussed would have discussed with the Kaggle data sets, and few data sets are considered as a benchmark by the journal reviewers. So actually I'm not sure about what is the demographic of the people who are audience of this workshop. Professor Hema, can you just give me the glimpse about like what are the various verticals of the participants? Professor Hema,
Ma'am, pardon, ma'am.
Can you tell me like what are the various verticals of the audience? All are like professors or teaching professors, or in which horizon are they working in a company, or like students are there?
Ma'am, mostly all are faculty members, ma'am.
All are faculty members.
Yes,
so
ma'am.
definitely all will be in the area of like publishing the papers and publishing the chapters. Am I right?
Yes,
I mean,
ma'am.
related
Yes, ma'am.
with the research point of the view. So all will be in the thirst of doing that, if I am right. Am I right?
Yes, ma'am.
Yes. Yeah.
You are
Okay.
damn correct, ma'am.
Yeah, so in that perspective only, my discussion and the focus will be there. So the statistics will be on one side, but on the other end, how are we going to give the quality research paper? That's going to be like an very important to be on the quite a better level in the case of our profession. Okay, in our profession now we are at the back of research papers only. It's a damn sure thing. Okay, so now coming on with this data analysis, so we are going to find like we are going to manually first check on with the data, and then when the data set is going to be huge, obviously the manual checking is not that feasible point of view. Then we will be relying on n number of the open source tools. Okay, don't think I'm just moving out of the Anaconda. I'll just get enter inside that also, and I'll get still more inputs regarding with the data analysis point of the view. So we are having n number of open source data analysis tools. Okay, so which will help us to make level like an first level of a checking point of the view. Okay, so the so to go inside like content, so as I said, the input may be like a combination of the quantitative or a categorical, and similarly the output will be like a combination of the quantitative or a categorical in nature. When it is going to be like in quantitative in nature, in the perspective of the machine learning, we are going to apply like a regression or the clustering method. When it is going to be like in categorical in nature, we are going to apply over the classification sort of a thing. And again, in the case of the classification, we are having the n number of algorithms to get over like a model point of the view. Okay, why is it necessary to make or ensure like data should be perfect? Are the data cleaning or data pre-processing required over there? So the reason behind that is, in the case of the modeling point of view, you'll be having the two options. It's like a training and the testing. So when we are going to put the data inside the training or the testing, we should ensure like it's going to be perfect in nature, so that the model which is going to be the output of any of the algorithm will be good in nature and so informative in nature. So ultimately, when we are going to discuss about this what's so called this sort of discussion over there. So we'll be focusing on the other area is like in domain area. Okay, so in which domain are we working over there? Okay, domain knowledge is very mandatory in nature. So at certain things like when we take about any of the application, no, we may not be getting much idea about that. The reason is like we may lack the domain knowledge. So definitely some domain knowledge input also mandate to get the informative stuff. So normally what we will be getting a data, will be trying to apply some algorithm. We may not even think about like cleaning the data. We may not think about that. So in the morning section, definitely you would have got a glance over like what are the data visualization. They would have used so many techniques to show the distribution of the data. Okay, so to certain extent, data visualization and the data stats is quite mid and middle, not like an entirely like a subset of the other, but quite mid and middle point of the view. Okay, so before going inside, what are the various methods are we going to use for the statistics? We will just see a glance about what are the various stats. Each and every one will be going on. Few will be telling like univariate statistics, multivariate statistics, and a few will be mentioning like a mean, median. So everything on, let it be on one side. So first we'll be seeing about in which way are we going to finalize the statistics. So which particular method am I going to use to find the worth of the data set, okay, to find the goodness of the data set, to find the fitness of the data set. So when we are trying to know this, then we can go on with the rest of the set of modeling or fitting the data set over the any of the algorithm sort of a thing. So as I started over like, so input variable maybe like in categorical or a quantitative. So again, I am going to have like an output. I'm going to just input after checking over like an input. I'm going to think over like what's going to be the output. So whether the output is a categorical or a quantitative. So when it is going to be categorical in nature, okay, input also categorical and output also categorical in nature, then I may be using the chi-square test to check the goodness of the data set, to check the weightage of the data set. Is it worth to work over, or if we are going to work real, it's going to be informative in nature or not. Okay, and coming on with this quantitative point of the view, again in the case of the quantitative also, the output is going to have either like an 1 or 0 only the binary is going to be there, or it is going to be having like an 1, 0, 2 as a target label. So hope all knew about like how the data set structure will be there. So it will be having like an for example 4 attributes, and 4 attributes values will rise on with the 5th attribute, that is a target or a label. Okay, target or a label. So based on the value of this 4, the output will be decided over there. So in this, the output will be decided. So the output is, if it's going to be having like a more than 1 in the quantitative manner, again certain division steps. So now it is going to be like number of groups to be compared is just the 2 over there. If the quantitative, it's going to be 2 over there. So I may be having this again the parametric or a non-parametric. So based on the assumption or without the assumption. When it is going to be non-parametric, I'll be using this sign test or a Wilcoxon rank or a Wilcoxon sign. So all this falls under the statistical analysis. So this particular chart gives you the complete information what stats are we supposed to use for the particular data set. Okay, and if it is going to be like in parametric in based on the assumption point of the view, then I'll be using on with the t-test. So t-test is a so common test, independent or a paired t-test, and then one sample test. And then coming on with like when it is going to be quantitative and 2 or more output, the 3 or more output is going to be there. Again, we are going to make all like a subdivision, number of output variables. So 1, again, I may be using like a Kruskal-Waltz method or the ANOVA method. So commonly all would have seen this ANOVA method, ANOVA, t-test, all this method are a common method in the statistics. So if someone is so strong in the statistics, it's going to be pretty easy. Once they're going to see over like a data set, they can infer like, okay, this is a method I'm supposed to use to check over the goodness of the data set point of view. So when it, on the other hand, when the 2 or more output variables are going to be there, again, ANOVA and the MANOVA will be used over like to find over like a goodness. And coming on with the quantitative point of the view. So now we have seen like its input is quantitative. Previously, we've seen like it's going to be categorical. When it is going to be like in quantitative in nature, and again there comes a 2 partition like a categorical or a quantitative. When it is going to be like our input is quantitative and the output is categorical in nature, I'll be using on with the logistic regression. And when it is going to be quantitative, again, I'll be having one or two or more methods, the simple regression or the multiple regression. Okay, so coming on with this quantitative with the quantitative, so we may knew about like a general equation, y is equivalent to ax plus b. So where a and b are like in variables and x is going to be like in constant, which is going to make the changes to check over the value of the y. That's a linear regression or the simple regression. So we have this so many things over there to make or like an overall checking sort of a thing, simple regression or the logistic regression, multiple regression. So as the name represents a regression, once if you see the name regression, then obviously it will be mapped on with the quantitative output point of the view. So when like it'll be like 1, 2, 3, 4, 5, 6, it'll be so the range will be so higher in nature. So apart from that, we'll be using all this methods to make or like a statistics point of the view. So I want you to just see it for a 2 minutes to get an idea. Okay. Okay, so can we go to the next slide? Okay, so next is like what are the various basic statistics? Okay, what are the various basic statistics that will be applying to the data point of the view? So as you very well know, like mean, median, and a mode. And mean stands to find like what is an average value of the data, and median stands for like a middle number of the data, descending on and putting in the middle number of the value, and mode is like number that occurs most in the data. Okay, so what is one of the purpose? Okay, one of the purpose to find out like this statistical output, it's like that it will be used to handle the missing data. Okay, that's going to be one idea. And other idea is like if it's having so much of outliers, okay, so much of outliers, how are you going to handle the outliers? So these are the and then other one is like so many dimensions are there, so many attributes are there, how are you going to? So normally in the case of the pre-processing stage point of view, so we'll be having this two arrays. So one is like an outlier data and other is going to be like a missing data. So to handle this both the things, we are making the statistical checkup. Okay, we are applying the various methods to find out like how far the data set is there. So based on it, the first one is a central tendency, mean, median, and the mode. So other is like a measure of variability, so standard deviation, so how much deviation is present in the data, so how far it is spread over there in this data, and minimum number and the maximum number. And other one is like in range, what is going to be like a largest number and what is going to be like a smallest number to make over. So all these things will be helpful while you're going to plot the graph. Okay, while you're going to plot the graph and to get like a more number of visibility or more number of accuracy point of view will be. So now for example, now minimum value is like and starts from the 4 and the maximum value is going to be like an 50. For example, I'm telling when we're trying to plot the map, instead of I'm putting like in from the 0, I can put like a 2, and in the maximum value we knew like now it is 50, so let's not put like 100 and waste that graph visibility pointer. So that's the other ultimate idea behind this statistics. And the other one is a kurtosis. It's a measure of tailoredness. It measures the sharpness of the peak, and skew is a measure of the symmetry. So all these are like a very, very basics of the statistics. So as per like a topic point of view, it is a very, very basics of the statistics. Okay, so to find other things like when we're trying to put it in the function in the case of the Python point of view. So describe that gives like a complete preview about how many counts are there, what is going to be like a mean value, what is the maximum value, what is the standard deviation value, what is the mean value, quantiles, and the max value. And similarly, we are trying to give an input. Okay. So now what I want all of you to download this data set in your system, and you have to work with me. Is it fine? Professors? Hello. Professor Hema?
Yes, ma'am.
Yeah, can you coordinate with me? I will be sending you this data set. I
Okay,
want
ma'am.
all of them to put in the system and they can parallelly work with me. Yeah.
Okay, ma'am. Ma'am, will you please copy that content and put in chat box, ma'am?
Yeah.
So that they can directly access that link, ma'am.
But I think it's not possible with the Google. I will. Can you just message me? WhatsApp. I can send it in the WhatsApp as a data file.
Yes, ma'am. Okay, ma'am. We'll put in the group, ma'am. Yes, you can send me,
Yeah,
ma'am.
yeah. Stop the creation. But I have the number of. Actually, I have the number of Professor Anand. Is he there?
Yes, ma'am.
Professor?
Yes, ma'am. You can send him, ma'am. I'll get from him, ma'am.
Okay, fine. Yeah, okay.
Okay, ma'am. Anand,
Yeah, yeah, he's there. He came online. I've seen him.
Another heart disease.
Yeah, I've sent.
Archive.ics
I guess you can just get it from the Professor Anand. I hope you have the WhatsApp group, no?
yes, ma'am. Yes, ma'am. They're having, ma'am.
Yeah.
I'll.
I'll send to.
Okay, ma'am.
Yeah,
I'll tell him, ma'am.
yeah.
அவங்க அனுப்பிட்ட அப்படியே மெயில் ஓப்பன் பண்ணு. உங்க எல்லாமே இன்ஸ்டால் பண்ணிருக்குல்ல.
Ma'am, it is there on the
Yes.
WhatsApp group now.
Yeah, Professor, you need not worry. We will be working in the Google Colab environment. I'm not going. Okay, thank you, thank you, thank you,
You can
Bharat.
as well,
Professor Bharat.
you can as well share the link through the chat box.
So
You can share the link through the chat box. Everybody can download through the links now.
Participants, we requested you to kindly mute your audio.
So Professor, I'm not going to work in the Anaconda platform. So I'll be working in the Google Colab. Okay. So hope all knew like we can work in the Google Colab and the Kaggle environment. Am I right? So how many used to work in the Google Colab? Kindly raise the hand. How many used to work in the Google Colab environment? I knew that this is meant for the Anaconda platform you have stated, but still like I'm just asking how many used to work in the Google Colab or the Kaggle environment? Professor Hema raised. Any other? Apasami, Professor Apasami, Professor Anjali. Okay. Professor Shailaja. Professor Bharati. Okay, like few have given like they are using the Google Colab. So others, if you are interested, if you are interested, you can go on with this Anaconda, or if you feel like still more easy or convenient, because we are not like an students to go on with using in the Anaconda platform. Okay, and again in the case of an Anaconda, we are not having the facility of the GPU. Yes. So what is the reason to go to the Kaggle or the Google Colab? Someone can tell. Professors, please be interactive.
Yes,
Yeah,
ma'am.
yeah, yeah. So it's like Professor Appasamy said, like GPU. Other than that, any other people wants to share something?
So we can use the cloud services.
We can use the cloud services. Okay. Apart from that, and it's not needed to download. Online execution is possible. So in the case of the Google Colab, we can upload the data. So whatever may be the size of the data, we can upload it inside that particular drive, that is Google Drive, which we normally use over there. And from there, we can retrieve it, or we can just input it inside the Google Colab environment. Okay, so I feel like all can open the Google Colab site, please. And other thing is like it's not required for us to bother about which is installed, which is not installed. So whatever may be the code, just import, just run as such. In the case of the Jupyter notebook, we need to pip install, all those stuffs are there. But in the case of the Kaggle and the Google Colab point of the view, it's not required to bother about what is installed, what is there or not. Just if we import those libraries and we can just put the required functions, immediately we can start executing over there. That's a main advantage. And second advantage is, as Professor Appasamy said, it's going to be like a GPU. So in certain data set is going to be so huge in nature, that time it's not possible to handle on with the Jupyter in the basic CPU. Otherwise we need to have the NVIDIA, like an Intel stuff for the GPU in our own system. So for that, we'll be relying on this Kaggle environment. And similarly in the Kaggle also, we have the notebook. So some would have used the Kaggle also. So how many have used the Kaggle environment? Kaggle environment. Anyone has used the Kaggle environment? Kaggle, please. Kaggle environment? No. Okay. Okay. So Kaggle also, like again, it is going to be very best. Like it's also provide us like an GPU support. Okay. In the Kaggle also we'll be having the GPU support. Similarly, in the case of this also we'll be having the GPU support, and it's not required for all sort of a data set. We require the GPU. Okay. Only when the data set is so huge in nature, and when you're going to work on with the image data sets, so there it is very preferable to have the GPU base, okay, rather than with the CPU. We need the GPU also. So yeah, I didn't use a TPU also is there right now in the Google. I guess it may be on the payment basis. I'm not sure about that. It may be on the payment basis. Okay, so I want you people just just 2 minutes break. Okay, it'll be quite noisy. Okay, sorry, professor. Sorry, really. Okay, so now we are discussing this particular stuff. Okay, so it's like an diabetes, heart disease data set. So where we'll be having like an attribute like an age. So age in the years it will be there, and then sex is going to have the two values. Either it is going to be 1 or a 0. 1 stands for the male and the 0 stands for the female. And similarly in the case of that is quantitative, okay, and age is also quantitative, but it is so varied in nature. But in the case of the sex, it's added only the two values, either 0 or 1. And similarly in the case of the chest pain type, we are having the four values: typical angina, or a non-anginal pain, or asymptotic. So that is again having going to have like in four values: 1, 2, 3, 4. And then resting blood pressure, it's in the and Hg on admission to the hospital. Again, it is going to be one numerical value. And then cholesterol, it is going to be expressed in milligram by mg by dl. And similarly in the case of the fasting blood sugars, okay, the fasting blood sugars, again they are making like a two variation. When it is going to be greater than 120, if it is going to be greater than 120, it's like a high blood sugar, so it's going to be 1 or a 0. It's a logical, it's not required much explanation over there. And similarly the next attribute is going to be like a resting electrocardiographic result. So based on that we'll be having like an 3 values. So each and everything is with certain rules, okay. And next is going to be like a maximum heart rate achieved, okay, maximum heart rate. So it's given by Katalach, that's one attribute. And the next is going to be like an exercise induced angina, 1 or a 0. So based on that, yes or no, based 1 or 0. And similarly old peak is going to be another one attribute. So it's depression induced by the exercise related to the rest or a sort of a thing. And similarly the next is the slope of the peak, exercise ST segments, and again number of major vessels colored by the fluoroscopy. So it's again TAL, normal or a fixed defect or the reversible defect. And finally the predicting attribute or the target attribute is going to be like an having a heart disease or not, diagnosing the heart disease or not. So this was the data set which I took from the UCI point of the view. Okay, so once if we get that particular any sort of a data set, before you're going to start working, just thoroughly analyze each and every attribute. Okay, thoroughly analyze each and every attribute. So today's session we are going to work on with this particular data set, and hope all would have received the data set in your right hand. Okay, and before getting inside this stuff, so as I said, we'll be having this mean, median, and then the mode. That's going to be like the first level of discussion. Okay, so if you're comfortable, you can work on with this Google Colab, or if you want, you can go on with the what's called Anaconda. So what is your convenient platform? So kindly all of you just enter inside the Anaconda, or my suggestion is Google Colab. Someone is telling something. I did. I guess rather than you are chatting, you can talk. I guess it'll be quite comfortable for me. Collab. Okay, yeah. So all can enter inside the collab. Okay, fine. And I want all of you to drive in the drive. You all knew this method. Drive.google. Okay, okay. All have uploaded the data, I guess. Yes. So you would have downloaded, and then right click, upload the files, and upload it from the downloads. Okay. Hope done. Okay. Actually, it will be very comfortable on comparing with Anaconda platform and other regular Jupyter notebooks and H2O, all those things. It will be very comfortable to work with the Google Colab environment. Okay. So first, let us go on with basic methods. So after that, I'll give on with this Pearson correlation, that coefficients, and then Wilcoxon's methods. So all those methods. It's not like only this much. So many things are there. Let us like confine with this stuffs alone. Okay, as of now. Okay. So in the case of this, so what are the various libraries required over there? So in the case of this, I'm just importing this import math and then import numpy as np, import pandas as pyd. So all these are meant for the data sort of a thing, for the data working sort of a thing. And followed by that, for plotting the graphs, we can go on with. So hope you can type, I guess. Okay, so this is meant for like an data. Okay, and then this is meant for like Pisan. Okay, this is meant for plots. Okay, and then this library setup is meant for statistics. Okay, so you can just copy paste all this library packages as such. Okay, and the next step is meant for connecting the drive. Okay, connecting the Google content or a Google Drive point of view. Okay, and the next what I'm doing is if we have placed that data set in the drive directly, if we place the data set in the drive directly, then this is the code which is meant to get that particular data set inside this working platform. Okay, I want all of you to complete this. So PD stands for the pandas, and this particular file is CSV file, comma separated value format file. So it's mentioned as read underscore CSV. So if it's going to be like Excel, I'll be mentioning it as an read underscore EXCL. Okay, so as I said, so on the top we have like in packages for the data reading, and then for the plotting the graphs for based upon the values which we are getting, and others is meant for the statistics point of the view. So these are the basic packages which we'll be using in the case of the stats, and based on here and there requirement, we can include that libraries too. Okay, the particular libraries could be included over there, and this is meant to load the or drive content. Okay, so now in this now they uploaded this hard data set. Okay, now we have uploaded this hard data set, and I'm going to mount the drive. Okay, so other way to mount the drive is, so when we start working here, the screen will be something like this. So like when it's going to take initial stage, when I'm clicking this folder over there, this particular stuff will be opening, and the top will be having a refresh option, and this is to load the drive. Okay, that mount the drive. Okay, mount this content over there. So as of now it is mounted in nature. So the data set which I'm going to take from this drive is, that's like content slash drive slash my drive. This is a path, the regular path, and the data set name is like an hard.csv. So I'm going to read this using this pandas package over there. So I'm just assigning that as a thread. So in few examples they would have mentioned as an df. Okay, data set, they would have mention of df, but now I'm just mentioning it as an train point of it's up to us. We can use any sort of the name. Okay, so before entering inside the, so hope all are ready till this. Yes,
Yes, ma'am.
Yes. Okay. Thank you. Thank you. So next step is going to, first we'll see like what is the shape of the file and what is the shape of the Excel file. All those things we can see. So thing is like trine dot shape of. So it clearly indicates like we are having 303 attributes. Sorry, 303 records, either rows or tuples, and 14 attributes are there. Okay. And the next is going to be like a trine dot size. So hope you can parallelly type and come, I guess. I mean, you can just check immediately. Trine dot shape, and then trine dot size. Okay, and the next important thing is like to check on with like an top 10, okay, top 5 or something. So top 5 trine dot head of. So if I put, it will be showing. So age, the first rate, it starts from the 0. So age is 63, and sex is like an male. That's what we have seen. No, 1 for a male and the 0 for the female, I guess. Sorry, 0 for the, which way I've given? 1 for the male and 0 for the female. I'm right. Okay, so similarly for each and every attribute, what is the value that is mentioned over here? And target is again like having the heart disease or not. So the function is like trine dot head off. Okay, and then next is going to be like in trine dot info of. So this trine dot info of, okay, exactly like it's going to be like an info of. This info of helps us to it lists all the attributes and what is its data type. Okay, so age is purely integer and sex is integer, and similarly CP, all these are coming in an integer point of view. So in the old peak, it is like a float sort of a thing. When it is a categorical, similarly it will be showing that particular data type, and it is mentioned like it's non-null. Okay, all are having values, it's not having any missing sort of a thing, and totally we are having like in 14 columns and 303 entries, so 0 to 302 entries. Okay, so all these things you would have seen in the data visualization. Am I right? Yes.
Yes, ma'am.
Yes. Okay, fine. So all would have completed till this, I guess. Trine dot info of.
Yes, ma'am, done.
Okay, done. Okay, so the next is we are getting inside the statistics. Okay, so very simple. First we'll be seeing descriptive statistics. All this forms under the descriptive. So mean of, train dot mean of. So it gives like in the case of an age, on an average in the entire 303 data set, on an average age is going to be like 54.36 value, and similarly sex is going to be like an so it's having 1 and 0. So it's having 1 and the 0. So it's having that different thing like 0.68316. So similarly for each and everything we'll be getting the mean value for each and every attribute. Another thing is like standard deviation, where we'll be using the std of. Okay, and similarly in the case of a median, we'll be using at median. Okay, mean, standard deviation, median, mode. So all those will be going on with the same sequence. What is the data set dot that particular function? Okay, std of gives the standard deviation, so how far the deviation is going to be there. And similarly median. Okay, and mean, standard deviation, and then median, and then mode. Okay, in the case of the mode, it will be giving like what is the maximum values it is showing. So in the case of the sex, 1 is higher in nature. Okay, again in the case of the data set, we'll be having like another one problem, imbalanced data set. So someone can tell me about the imbalanced data set. What do you mean by imbalanced data set? Is it good to work with the imbalanced data set as such?
Say, but imbalance data set means if I mean, say if you want to distinguish between the two different aspects or like that, so for there should be equally say around 50% data set for the one category and 50% for the another category or like that.
Okay,
Whether it will be,
it should be.
yeah.
Okay, if it's not there, what we will be doing? If it's not there, if the balance, if it's going to be imbalance in nature, what we'll be doing?
Then our results can be little bit biased with respect to the which data set larger we have with respect to that. Our result can be oriented or biased with respect to that.
Okay. Okay. So what could be done for that to avoid that?
for that I don't have that much idea, but
Okay.
madam.
Okay, fine. So thank you, sir. So in the case of this, one method is like we'll be using the SMOTE method, SMOTE method. So in the case of the images, okay, in the case of the images, we'll be going on with the image augmentation. Okay, we'll be going on with the image augmentation. So how many knew an idea about the image augmenting the data? Professor Appasamy sir said like we'll be having augmenting the data. So it's like whichever the data set is, so I mean which combination is so less, we will try to include number of records that matches the other thing. That's what he's mentioning. I can augment the data. Multiple people wants to, Professor Hema, this multiple people wants to join this call. Accept all, or what to do be done? Okay, thank you. So we'll be going on with this augmenting the data. So when it is going to be like an image, okay, when it is going to be like an image, they'll be like flipping the image, or they'll be putting it in the left to right, they'll be top and bottom, or they'll be slightly changing the skewness of the image. So that way they'll be taking. So in the case of this, one of the method to handle over in the case of a regular data point of view, will be using the SMOTE method, like synthetic minority oversampling technique. They'll be oversampling. They'll be putting like a still more data which is very less in nature. For example, if 300 is going to be there, out of this 300, 150 should be on the 1 and 150 should be on the 0 point of view. If it's going to be like a 3 classes, similarly 100 it should be there. But frankly telling, when we are going to collect the data, in the real time, it's not that easy to get the data without all these issues. Okay, there will be some issues over there. So few will be on the more target, and other will be on the other sort of a thing. So it's very critical, or it is very, very important to handle this, to manage this, to how are you going to overcome this. That's going to be. And similarly in the case of the image also, we will be augmenting only on the training data set. So in the case of the model, we'll be having this augmentation. We'll be augmenting only on the training data, but will not augment on the testing data point of view, because we need training data should be high. And normally when we work on that, we'll be saying like training accuracy should be higher than the testing accuracy also. This is like an other area of this machine learning or the deep learning point of the view. So in this case also, we have to check on with, so when it is going to be so skewed. So as Professor Bharti mentioned, the data will be so skewed in nature. So then the information or the decision. So ultimate aim of any of the data set or data stuff is going to be like, we are going to retrieve some decision. Okay, for instance, if we are going to discuss about like an air quality index. Okay, now we knew like air quality is it's a very problem. Okay, in all across the globe we are having this problem. So you would have seen like near our education institutes also, like one board will be kept which will be showing like this is the quality of the air as of now. So and we all experience like when we move out of this corona point of that time, we felt like environment is so nice. Even like clouds, if you see, it'll be so white in nature, like pollution free sort of a nature. And so how are we going to handle this? So what are the decisions are we going to do? So recently you would have seen like in the Delhi, they have mentioned like we should not use vehicles frequently, and let's go for the online classes. Yes, have you seen those newses? Professors, please. Yes. Okay. So Professor Anjali, can you just tell me like how they when entered inside that particular, okay, yeah, really, this is the time to wake up. I mean, this is time to realize that our environment is going so bad. How are you going to safeguard that, right? So, Professor Anjali, can you just tell me, like, glance of the Delhi incident, air quality index stuff?
Like in Delhi, right now the air quality index is very poor. Like if we move toward the Hojkas range or the area which is very densely populated, even the people are able to see, they have so much irritation in your eyes. Oh, and the level, it's already like the people are facing that the kids are having chronic problems as well. The elderly ages, even the kids and as well as the elder person, the main group is very much affected towards this.
Can you just tell me what is the reason behind that, Professor Anjali?
Sorry?
What is the reason behind that?
what is the reason behind them?
It's a capital. It's India's capital, but
Yeah.
very bad to think about or talk about. Like capital itself is so polluted, and it is not the good sign actually. So can you tell me what are the various reasons that could be said for this pollution?
Ma'am, there are a lot of reasons which is actually giving a fuel to this, a lot of like pollution stuff is going on. We have festivals, like Hindus celebrate festivals in a very good manner. They don't care about that whether we are able to breathe or not. It's
Yeah.
about the festivals.
Okay,
Okay.
then
That's also a mindset that people are ongoing, and they are not a very good amount of energy that we are in a good reign to stop that. Right, farmers protests are also going on in Delhi, and there are a major number of chaos
but
going on
but
because
if
of
I
it.
want to put in this way, like farmer stuff is going on for the past 1 year, but the pollution of the Delhi is not for the 1 year; it's for the past 10 years. It's not like a new stuff. So I can put it in this way. The first reason is population is so high in Delhi.
True,
Like people staying in per square feet on comparison with the other cities and the Delhi, maybe Delhi and Mumbai will be going on the same way. So that's going to be like the population is so higher in nature, dense population. And the second is due to this population, obviously the usage of the vehicles, usage of the automobiles is so higher in nature. Okay, and apart from that, the number of factories or industries running across or on the Delhi is going to be quite high. And other main reason is like the dust or that smoke which is created by the adjacent place. Like if I'm right, Rajasthan, right?
a lot of construction work is always going on in Delhi. You
A lot
can
of
see
construction work is also going
the
on.
metro lanes and the construction lanes, and you can easily view that the number of population is increasing, so they need infrastructure for that also.
Yeah. So obviously in the Delhi maximum like tourist spot is like all like monuments like it's going to be a monuments point of view. That is also so higher in nature. That tourist population is so higher in nature. So roughly, if you would have said like I've given like an 6 reasons. Okay, 6 reasons, and the target is going to be like an air quality index. Okay, target is AQI, right? Target is AQI. So apart from that, the rivers are flowing, which is again polluted in nature. Am I right, Professor Anjali? I mean, certain water bodies are not exact rivers, so water bodies. Certain water bodies also, what to say, polluted in nature. So like this, so many stuffs are there which contributes to the contamination. Yeah, contaminated in nature, polluted or contaminated in nature. So it gives that value to the AQA. So when the AQA is so high in nature, it will be giving the red alarm for them. And based on that, the government agencies are trying to take the decision. So Professor Anjali, if I'm right, are you residing in Delhi? Am I right?
Right, ma'am. I'm in Delhi.
Yeah. So what are the various decisions they have taken in the recent days by our government, Indian government?
Time to time they have taken very much initiatives, like sometimes
I want to hear those initiatives actually.
Like in the pollution levels, when the pollution levels goes very high, the Delhi government generally, that is Aam Aadmi Party government, is going on in Delhi, as they have started the odd numbers and even number vehicles day, odd even kind of scenarios they have started. And mostly what they have just do is in the areas like the pollution in the petrol pumps, near the petrol pumps, they have a huge amount of plantation has already also going on. Like they have connected so that the air quality index also improves a lot. Okay. And they have frequently they have stopped the from till 15 they have stopped all the constructions work which is going on in Delhi. So there is no construction work going on because the pollution levels are increasing day by day. So kind of this the good things, good initiatives are done from their side to improve the air quality index for all. And similarly, the people also take initiatives in growing more plants towards the good agriculture and good air index. So that's the only initiatives they.
Okay. And
All
other
right.
thing is like this smoke which comes from the Rajasthan. That is really so bad, I guess. Like it's like an yellow dust in China.
Very,
In the
very,
China, we
very.
have this yellow dust which flies from the adjacent place to the China, and that time the complete area will be like so dusty in nature, smoggy, like fog with a dust, smoggy in nature, sort of a thing. So that's so similarly. So now, why I put this question is like, so to take some decision, we need like an perfect review or a perfect input. So we now like so many what to say satellites and other stuffs which helps to gather the correct data, in turn that helps to make the environment I mean in this particular case to take some solution to ensure like environment is safe in nature point of view. So this is how like we'll be thinking on with various attributes and how that attribute is going to have the influence on the target point of the view. Okay, so coming on with this, so to take the decision. Okay, so we will just get inside this. So try dot mode to get the maximum values, and similarly minimum. So what's going to be like a minimum value of each and everything. So in the case of an age, 29 is age is a minimum, and a zero, so it maps to the quantitative point of view. And then try dot max, so maximum value is like in 77, and then that bps is going to be 200, and cholesterol maximum is going to be 564, and talat is going to be 202. So all those things are there. And similarly SEM, then error point, that is an error measure, and this is skewness, and this is kurt I mean kurtosis, KURT. So I want all of you to just execute all this stuffs for 2 minutes. Okay, and finally all can try and see describe of, which will give the summary of the entire stuff. Okay, so describe of, so apart from that, the other thing which we'll be mentioning is what's going to be like an entire count. Okay, how many counts are there? So all are 303, 303 only. And as usual, mean, standard deviation, minimum value, and then maximum value, how much is 25% top, and then the 50%, and then the 75%. Okay, Dan? Can we go on to the next? Okay, professors?
Yes, ma'am.
Okay, thank you. So the next is like, I'll just give small glance. You can even make still more try. So statistics per group. Okay, so now here I am trying to group by cholesterol with the rest of the attributes. There is no hard and fast rules. So statistics per group, where we'll be using like a group by. It is something equivalent to the SQL statement sort of a thing. So trying of group by and which attribute I am going to group on which particular parameter. So I'm just trying to map with the mean of point of view. Okay, you can just try it. Trying dot group by of cholesterol is an attribute, and again I'm making it on the point of the mean point of view, that particular attribute point of view. So you can try on with the other attributes by combining with the other attributes and try to find like a relationship point of the view. Okay, so the next is going to be like group by statistics. And similarly, I am trying to make only with the age point of view, not with all the attributes, only with the age point of view, cholesterol with age point of view. So similarly, you can try on with few attributes too. Done. So all these things which you have seen, all are like an basics. Okay, all like a basics, and group by is for like a very simple stuff. Okay, the next stuff which we are going to do is like an ordinary least square method. Okay, this is like fitting the model using the style. It's an ordinary least square. So now here I am making the comparison between the cholesterol and EXANG attribute alone. Okay, and to compute that OLS stands for that particular function. So it's that's a stuff, and the formula is equal to target. So the target is a label. Okay, that we use a target. So the target is getting mapped with cholesterol and EXANG alone. Okay, so that's what like this tries to indicate over like. Copy cell. Control V. Enter. And then here I am trying to make the stuff only with the cholesterol and EXANG attribute, and I'm going to print the summary. Okay, so what is the purpose of this? So it's one of the major method in the case of the statistic. So you can see here what is the result it is showing. So method is least square. Okay, and the dependent variable is a target. Okay, that's a dependent variable. And you would have heard a word like an AIC, BIC, all those high values should be a bit higher in nature. And in the case of this, so how the intercepts and all those values are there. And frankly telling, who are so well versed in the statistics, they may understand still more better. And so what is the skewness, what is the cortesis? So during this particular combination, how are we going to get this regression results? So based on the regression results, we'll be going on with the deciding which particular combination is going to get the better results. Okay, so now I want you to just try with some other two attributes and check. So now you knew like what is the format of the data set. Okay, now I use this cholesterol and EXAG. I want you people to use some other combination and check, and when this AIC is going to be higher in nature, that is the best fit, or that is the best stats point of view. So I request you to check with some other attributes. This is OLS, stands for the ordinary least square statistics. Ordinary least square statistics. So tried professors, are you able to see the different results in this summary when you are going to use the different attribute combination with the target could be changed. That's going to be like label. So if you're trying with the different attributes, definitely you'll be seeing the different results, right? Am I right? Yes. Okay. So I want a small favor from you people, like I'm just sharing one link. So I am working on with trying to work on with the new data set to make a review about like an online education system, the students are satisfied or not. So I request you kindly to share with your students and ask them to fill the form. Okay, this is only for the research purpose only. This is a favor. I request a favor from you people. So completed. So all tried some other combination and are being for like different summary will be popping up, right? Right? Am I right, professors? Are you? Okay, fine. Thank you. Tried it with FBS. So different results you'll be getting actually. Okay, A is 379.2. So with FBS, it is showing better results. So again, I want to, so today morning, have you just checked on with the correlation in the data visualization? Have you seen the correlation type? Like all the attributes together on the left and the right axis? Yes. Left and the right axis. So which is having the positive correlation, which is having the negative correlation and neutral correlation. Am I right? Process, please. Positive correlation and the negative correlation. Okay, fine. Okay. So the next thing is like, so this, you can try and see this ordinary least square method. And similarly to in this also to check over like each and every that intercept. So we'll be using res.params. So this is a continuation of the previous thing. And dir of res gives you like what are the various functions that could be used with it. What is an intercept and what is in cholesterol, like a equation we can write this stuff. Okay, res.params. And other things is dir of res. So this gives like a directory to show all the functions that could be done with it. Okay. And the next, so it will be listing so many things. Okay, so the next is going to be like another one stats called as an linear underscore rainbow. Okay, it's again one sort of a stat that just mentions this intercepts value point of view. Let's move with the other stuffs. Okay. So Wilcoxon method. Hope all would have heard of letter alphabet P. Okay, in the case of the hypothesis, we'll be stating an hypothesis based on the P value. Are we going to accept that hypothesis or are we going to reject that hypothesis? When this significant result, I mean, this P value is less than or equivalent to 0.05, we will be rejecting that particular hypothesis, test hypothesis. Or when it is going to be greater than 0.05, we'll be like trying to check over and we'll be accepting that. So based on that condition, we will be making use of this input I didn't given in the very beginning. So I just want to import that. Okay, SkyPy.stats as a stats, and for the Wilcoxon, it's one of the method to get the P value. So P value greater than 0.05 means that no effect was observed over there. So it will be giving, so all the is the Wilcoxon method and the other methods, it will be giving two things. So one is a statistics value, and other is going to be the this p value. So based on this p value, we'll be coming to the conclusion: are we going to accept that hypothesis or reject that hypothesis? Statistical significant test results mean the best test hypothesis is false or should be rejected. A p value greater than 0.05 means that no effect was observed over there. Okay, so this is one method, and similarly this method, and the other one is in ANOVA method. So you can very well see, like in the case of that this method, I have used the age and cholesterol. Okay, I've used the age and cholesterol. In the case of an ANOVA method, I have used the age and test BPS attribute. We can just try and see the various values and see how the values differ over there. So this is all this comes under the p value point of the view. And in the morning, you would have seen the what's so called correlation stuff. So this Pearson correlation and then the Spearman correlation. So these are like a very famous correlation method. Again, it gives a value. So when this value is going to be quite higher, it shows that it is closer. The relationship is very closer in nature. And in the case of the p value, normally the alpha, they'll be calling them as alpha also. So alpha is normally considered as an 0.05. Okay, 0.05. So based on that, will be going on. And in the case of the Pearson, okay, in the case of the Pearson or the this is for the Pearson, P-A-R-S-O-N-R, Pearson value. So again, it will be giving the stats value, I mean Pearson correlation value. When the value is going to be higher in nature, it indicates that it's having the positive correlation and relationship is so high in nature. So these are like a few examples. So one is with an age and the cholesterol, and other one is with the age and the stress BPS. It's up to you. We can find it. And today morning you would have seen like an correlation for the entire. So from that you would have inferred like how this correlation have the positive response with the one or other attribute point of the view. Okay, so that's a thing. And this is with the Spearman. And other is like an ANOVA, which is meant for the p value. Okay. These are like a few correlation and the p-value stuff. So very few, like a Wilcoxon, and then this ANOVA meant for the p-value point of view, and these two things are meant for the correlation point of view. So if you just try this for, so whatever may be the side, so you can get like an now I mentioned scatter, so it will be giving like a complete overview about like how far the data is prevailing inside that particular data set. I mean, how what's going to be like a flow of the data over there. Okay, and this the linear regression stuff called as an reg plot, REGPLOT reg plot. Okay, so here the target is y is kept as a target, and x is on the cholesterol point of view, and I'm trying to plot that. So now I want you people to check on with the various combination of the Spearman and then the Pearson and then the other stuffs. So 5 to 10 minutes. So after that, I thought of discussing another one new concept. Professors, I've shared the collab link, like in which I'm just showing those results. No, so I have shared it. You can just use that code as such. Okay, Professor, is it fine? Who asked, like Professor Patil, Pradanya Patil. Okay, so you can take and you can just work on with the other data sets too. Professor Hema, I didn't complete my session. So can I continue right now? Professors, please.
Yes, ma'am.
Yeah, yes. Okay, so now all this time I'm just seeing the showing the code stuff. Okay, test is there. Okay. So all this time I'm showing, like, I guess session is from 2 to 4. Am I right?
Right, ma'am.
Yeah, right. Okay, so I have some more time for me. Right?
Sure, ma'am.
Sure. Okay. So normally we all people once see the test link and feedback link will stop listening. That's the reason I'm asking if it's over, like I can just move on instead of spending time. No.
Yes, ma'am.
No, like, do I need to continue or I will be going?
Yeah,
on
you just continue, ma'am. Continue, ma'am.
Okay, fine. Okay. So
Okay.
now I'm just going to the extremely out of this Anaconda, Google Collab, all those things. Whatever things we have done right now, okay, whatever things we have done right now, we can just do it within few minutes. Okay, that's going to be the discussion right now. Okay, how many knew this orange tool? Professors, please. How many knew this orange tool? I've heard this tool called as an orange. No, okay, then it is very really useful for you. Okay, till this time and till all these sessions, you are just going on with this. It's just a fast look for 10 to 15 minutes, not 10 minutes, not more than that. Okay, so I knew like you all will be hurry. We all also used to attend, and towards saying we all will be so tired. Okay, when it will be completed, when we can move out. It's a possible thing. Okay, so I want to just go on with this orange tool. Okay, so which will give you like all these things which you have done. No, so it could be done in few minutes. Okay, so hope the screen is visible. Am I right? Yes, Professor says screen is visible, right?
Yes, ma'am. Visible, ma'am.
Orange, it's like an on tool. Am I right? Yes.
No, ma'am. No.
Okay. That's the reason
Okay.
I'm asking. Stop presenting and present now. A window. Yes. Yes, professors.
Yes, ma'am.
Yes.
Same.
Okay. Yeah. Now what this is like an orange tool. It's very, very user-friendly tool. I agree with you. You all people working with an Anaconda, you work Google Colab, Kaggle, everything. But this is a very user-friendly tool. You can just download in your system just like that. And here I have inputted our data. Okay, here I have inputted data. One trick here over is, so it will be showing all this as a feature. The last one, whatever may be like a target label, we need to just change it to the target. Okay, the feature is like a general attribute name. We'll be just changing it to the target, right? So target I'm changing and I'm going to apply that, and I am fed the data inside this tool. Okay, so we are having so many widgets in this. Okay, we are having a data widgets, we are having the visualizing widgets, and similarly we are having the model like meant for a machine learning sort of a stuff, and we are having this evaluate, which is meant to find the accuracy percentage, all those, etc. So since my topic is containing with the statistics point of view, I am not going to touch the rest of the stuff. I will just go on with this particular stuff alone. Okay, so 5 feature statistics, one widget called as in feature statistics. So what are the things which we are done till this right now? It will be, we could retrieve it within a minute, not within a minute, also within like few seconds. So age, so distribution of the age is this way, and the mean value is 54.37, and the median is going to be 55, and the dispersion, and then minimum value and the maximum value, and the missing is completely 0% On a contrary, if a data set is having some missing value, that percentage will be shown. So similarly, it shows all the attributes, mean, medium, min, max, all those values, right? Okay, this is one sort of widget. Another is a data info. So it's a very short little bit showing. So rows is 303 and column is 14, and we are having the 3 categorical values and the 10 numerical values, and categorical outcome with the 2 values. So like a 1 or a 0 we have seen, and there is meta attribute no, and data location stored in the memory. So this is data info, similar to the data.info over there. And this is a correlation. So Professor Bharati, I guess, she was just trying with the various combinations. She's telling me. So this is the correlation of each and everything. So in this case, we are having the 2 correlation, Pearson and the Spearman correlation, which we discussed right now. In the case of the Pearson correlation, so between like each and everything, what is going to be the correlation value between the old peak and the slope. So what which we tried is like an age and the cholesterol. So 0.214. This green color indicates like it is a positive correlation, and then this color indicates like it's going to be like a negative correlation. Am I right? So this is very easy method to find like Pearson correlation or the Spearman correlation. Inside the formula is there, I agree. But frankly telling, as a pure computer science people, we will not be having much knowledge on the stats point of the view, but this tool helps us to get the values very easily. Okay, and similarly, the other thing is in a rank value. So we have discussed about the ANOVA. I didn't discuss about the chi-square. We have discussed about the ANOVA method. So this helps us to give that which attribute is really having the higher relationship with the output point of the view. So it's information gain and the information Gini index, Gini. So all this helps to. So now while you're going to use this, you would have heard about like and which feature is going to have the higher value, are having the higher influence towards the output point of this. So for the feature construction point, so we can, so using this gain ratio, THAL is having the higher influence on the target point of view in the EXANG, CP, CA, and the slope. So all this having the higher relationship on with the help of this particular ranking method. Okay, the other thing is in box plot. So hope in the morning you would have written small code for this box plot point of the view. So what's going to be like a minimum value, maximum value, and average, and what's going to be like a p value, and then the number of things considered as 3.03, and statistics is going to be like in 4.093. Okay, so this is a very, very simple tool which helps to give you the complete preview. What are the things which we does using the code point of view? This could be done with the help of this orange tool. Okay, so what is the name to? You can just put orange download. You can get it. Professor, I guess someone. So you can get it very easily in this. Okay, so other thing I like to share with you is, so you may ask me really this orange tool, and how many used Veka tool? Yeah, good. Thank you, Professor Bharati. Veka tool. Have you used the Veka tool? WEKA. These are like an added information. Okay, I thought I can just take for that and add. Okay, this is another one. Veka tool is another one. Amazing data mining tool. Okay, do you want to see that? I guess I'm not having in the system. Anyway, let me check once. I'm not having that in the system as of now. So you would have heard they can UCI repository. So that and these are like relatives to each other, like. From the SourceForge also you can download, or from the Softonics also you can download. There is no hard and fast rules to download the Veka tool. So the Veka tool is another one amazing open source tool, and it is very, very easy. Okay, it's very, very easy to work with this Veka tool. Okay, and R can also be used. Professor Anna Devi says like R can also be used. As I said, like Google Colab, all those things will be going on in the coding. But this Vecca, all those stuffs, it's not much coding stuff is required. Okay, it's like drag and drop, just putting. And even in the case of the Vecca tool, Vecca, University of Waikato, it's given by New Zealand University. So in that, we can even apply the deep learning. We can do the deep learning using that Vecca tool. So have anyone used this Vecca? Anyone tried this Vecca tool? Have anyone tried Vecca? Okay, you can get that from here. So this is also very easy tool. You can just drag. As of now in the system, I'm not having this Vecca. So you can just drag. You can just import that particular data file, and then you can apply all sort of stuff. You can do all sort of algorithms. All classification algorithms could be done, and obviously the accuracy will be coming out. Training and the testing accuracy could be get. Ma'am, I use data mining technique. Yeah. Protestant, that's what I'm trying to convey. Like the Vecca tool could be used over. So in the Vecca, we are having the technique even to handle the missing data smooth method, SMOTE method. That method is available in this Vecca tool also. Okay, so other than that, you may ask me like whether this stuffs will helps to publish the papers. Definitely. Okay, definitely. I say like, are you able to see my PPT screen? I mean PowerPoint? No, I guess.
No, ma'am. No.
No. Yeah. Stop presenting. Share presenting. Window. And the stats is in PowerPoint. Okay, so this is the data set which we are discussing right now. And these are my recent works. So in all these works, like I made use of the orange, I made use of the Google Colab, and if all the work is done by and few stuffs I use the MATLAB also. So this Bayesian regularized neural network for analyzing Bitcoin, I use the MATLAB. And for this plant leaf disease detection, I have used the combination of the orange and the Google Colab. So for the visualization, I will be using the orange. And similarly, this machine learning way to classify autism spectrum disorder, I use the orange, Max Orange and the Vecca, I guess. And similarly, this heart failure patient, similarly, orange I have used. And in this prediction of suitable candidates for the COVID-19, I use the Google Colab for this stuff. Okay, so all this works maximum I used to work in the combination of the orange, Google Colab, and sometimes use the Kaggle, and along with that MATLAB, and then the what's so called Vecca tool also. Okay, so if any queries at any point of a time related with this machine learning, deep learning, or any sessions needs to be conducted with the open source tools, machine learning or a deep learning, feel free to contact in this mobile number or the mail ID. This is a VIT mail ID. So any queries as of now, I am ready to answer. So hope I satisfied your requirement. I mean, you would have thought like this, what I want to learn. I guess I satisfied that. Am I right? I'll just go to the chat box.
Participants, if you have any queries, you can unmute and you can ask your doubts and you get clarified with our resource person. Participants, you can unmute and you can ask your doubts.
So linear regression is y is equal to mx plus c. So that's what which we study, regression, that stuff actually.
Ma'am.
Yeah.
I want to print that regression equation that is coming out of the program.
Yeah,
you will get actually the values. Ma'am. I want to print the equation also. How to print it?
You can get from the intercept and print, Professor.
Okay.
So if you feel like I handle normally the sessions with an orange for 2 or 3 days, because now I just shown like a glimpse of that. We are having so many functions with that orange, and similarly in the Vec also so many stuffs are there. So it's not possible like all can just go on with coding. So for those people, definitely that open source tools are much helpful in nature. Even if I am right on comparison with the Anaconda, putting all the stuffs, Jupyter, this platform, it's very comfortable to work with the Google Colab. What do you say? What do you feel, professors? Actually, am I right in this context? Am I right in this context, professors? I want some input from you people.
Yes, ma'am.
Yeah, obviously it's very easy, you know, like rather than coding all the stuffs and finally getting some outputs, it's a bit easy, I guess. So any other inputs required? And if you feel like you want to make some collaboration, even the collaboration works, or like I'm interested to do even do that also. Thank you, professors. Anything else to be discussed? I guess whatever thought I want to discuss with you, I have completed, including this orange, giving some input regarding the orange and the Veka. But we are having so many tools also. Neil, Kale. Have you had KEL? Keel. Keel. There is another one thing called as in Keel, knowledge extraction, something like that. So that also helps you to give like and then open refine. There is a Google stuff, open refine. That also helps to give like a better stuff in refining the data set. I mean, data cleaning point of the view.
Participants, we requested to fill the feedback form that was posted in the chat box. Participants, if you have any doubts, you can clarify it with the resource person. Thank you so much, ma'am, for an outstanding session.
Yeah, thank you, Professor. Thanks for the opportunity given. Actually, first.
Okay, ma'am. Actually, we have to thank you, ma'am. You have cleared all the doubts and you taught in a very nicely manner, ma'am. Thank you, ma'am.
Yeah, thank you. So in the future, near future, if you want for students also, I'm ready to handle like related with this data mining, machine learning, deep learning stuffs. So recently all my works are with the deep learning and the image processing stuff.
Okay, ma'am.
And
That's
few
good.
of the papers like they've highlighted in the WHO website also. If you just go to the WHO website and see, nearly like 3 or 4 papers I have published related to the COVID data set.
Okay,
So
ma'am. Okay.
those papers are highlighted in the WHO website also. Okay, so thanks for your wonderful cooperation, all the professors, like on and off you are, because always being calm, no, it'll be not comfortable for the people who are taking also. So really thanks for all the people who have cooperated with me. Thanks a lot.
Thank you so much, ma'am. Thank you, participants, for an active participation. And we request all to meet tomorrow at 9:30 a.m. for getting depth knowledge about Anaconda data science techniques. And thank you, everyone. Have a great day. Thank you so much, ma'am. Ma'am, somebody is asking for show the slide.
Yeah.
Ma'am, somebody is asking for share the slide, ma'am.
Yeah, sure. I have shared the, I guess I have shared that, what to say that code link actually. That is more useful actually rather than this slide. And
Okay, ma'am.
only different thing is only this one is quite different, I guess. The rest is fine, I guess. See this.
Okay, ma'am. Ma'am, anyway, you share your slide also, ma'am, so that we'll send to all participants as learning materials.
Yeah, I will, but max like the same stuff only. I will.
Okay, ma'am. Okay,
Sure,
ma'am.
I will send to Professor Anand, right?
Yes, ma'am.
Yeah.
We'll
Thank
get
you.
some.
Yeah.
Thank you so much, ma'am.
Immediately I will send. Yeah. Thank you.
Okay. Thank you, ma'am. Thank you, participants. Thank you all for being with us today. We will meet tomorrow at 9:30 a.m. for getting depth knowledge about Anaconda data science techniques. And thank you, everyone. Have a great day. Thank you all.